Hey everyone, welcome back to the channel. Today we are going to tackle a popular coding problem called threesome. This one is a classic for technical interviews because it requires a good mix of problem solving and optimization skill. We'll go through the problem, dive into the solution in C Sharp and break down each line of code so you can understand exactly how it works. Alright, here's the problem. We are given an array of integers called nums. Our goal is to find all unique triplets in the array that adds up to 0. Each triplet will contain 3 elements and we need to make sure that the triplets don't have any duplicates. For example, with the array nums equal to -1, 0, 1, 2, -1 and -4. There are 2 unique triplets that sums up to 0, -1, -1 and 0 and -1, 0 and 1. The order doesn't matter and neither does the order of the element in each triplet. When I first tried to solve this problem, my instinct was to go with brute force approach, basically testing every combination of 3 numbers with an O cube time complexity. This solution became inefficient really fast. It wasn't until I came across the two-pointer approach that I was able to optimize any solution. So if you're facing performance issues with a brute force solution, hang tight because this approach will help. The optimized solution involves a combination of sorting and two-pointer technique. Here's the plan. We'll first sort the array to make it easier to skip duplicate values and work with pointers. Then we'll use a loop to fix one number in the triplet and use two pointers to find the other two numbers. This way, we can achieve a time complexity of O(n) square, which is much more manageable. Alright, let's dive into the C# code. Let's walk through this code. We'll start by defining a method called threesum, which takes in an integer array nums and returns a list of lists containing our unique triplets. We are using ilist of ilist int here to keep it flexible. The first thing we do is sort the nums array. Sorting is key because it allows us to skip duplicates values easily and use the two-pointer approach effectively. Next, we initialize a list called result, which will store our unique triplets. This is what we'll return at the end. Now we start a for loop to fix the first element of each triplet. This loop runs from the beginning of the array up to the nums.length -1 because we need space for other two elements in the triplet. Inside the loop, we have a check to skip duplicate values for the current element. If num I is the same as the previous element, we just continue to the next iteration. This helps us avoid duplicate triplets in our final result. Next, we set up our two pointers. Left is I plus 1, the element right after our fixed element, and right is at the end of the array. This pointers help us find two other elements that complete the triplet. We enter a while loop that continues as long as left is less than right. Inside this loop, we calculate the sum of nums I, nums left, and nums right. If sum is 0, it means we have found a valid triplet. So to add this triplet, nums I, nums left, and nums right to our result list. But we are not done yet. To avoid duplicates within this triplet, we use two more while loops. This while loops helps us skip any duplicates values for the left and right. If nums left is same as the nums left plus 1, we increment left. Similarly, if nums right is the same as nums right -1, we decrement right. This makes sure that each unique triplet is only added once. After processing a valid triplet, we move both left and right inward by one step. This will help us explore other potential pairs without repeating values. If sum is less than 0, we increment left to get a larger sum, since the array is sorted in ascending order. If sum is greater than 0, we decrement right to reduce the sum. Finally, once we have looped through all possible triplets, we return the result list, which contains all the unique triplets that sums up to 0. To sum it up, by using sorting and the two-pointer technique, we solve this problem in O(n) square time complexity, which is efficient enough for most cases. This approach not only eliminates duplicates but also helps us avoid the inefficiencies of a brute force solution. personally, solving problems like this has taught me a lot about working with pointers and optimizing for time complexity. The key takeaway here is that understanding techniques like two-pointer can make a huge difference, especially for problem solving or involving combinations or sums. Alright, that's it for today's video. If you have enjoyed this tutorial, don't forget to give it a thumbs up, subscribe and hit the bell icon for notifications so you don't miss any future videos. Let me know in the comments if there are any coding problems you'd like me to cover next. Thank you for watching and happy coding.